Malulu.
And don't put it to back into bed again. And now I'm start to again.
Want to sleep? Go and sleep now.
Good afternoon, all of you. Joseph Bamidele. Joseph, I request Joseph to be on mute.
Hello, good morning, sir.
Good morning, sir.
I'll be speaking.
Yes, sir.
What's that thing?
Sir, can you please state your paper ID?
We have two papers to present, 454 and 455. But I think the 454 is in the afternoon. It's only 455 we have now.
Okay, sir. Thank you, sir. I request you to please be on mute.
What do you say, sir?
Good afternoon.
Good afternoon, ma.
Good
Yeah,
afternoon, ma'am.
I'm so sorry because of some technical glitch. I am late.
No issue.
So,
Thank you so much, ma'am.
yeah.
We are just starting our session.
Okay, no problem.
Welcome all of you to session 4. A very good afternoon to all of you. Am I audible?
Yes.
Thank you.
We are hearing you.
Okay, thank you, sir. A very good afternoon to all of you. On behalf of Department of Computer Science and Engineering, NIT Raipur, and 4th International Conference on Machine Intelligence and Signal Processing, MISP, I welcome all the respected session chairs and participants. Before we start the session, let me introduce to our esteemed session chairs. Our first session chair is Dr. Simranjit Singh from Bennett University, Noida, India. Dr. Simranjit Singh is currently working as an assistant professor in Bennett University, and also he has more than 6 years of experience in research. He has done his PhD from Thapar Institute of Engineering and Technology, Patiala, and completed MTech from Punjab University, Patiala. He has developed various deep learning framework for classification hyperspectral data. He also developed a quantification framework to quantify the various soil attributes. He has published many research papers in the field of deep learning and hyperspectral image analysis. Our next session chair, Dr. Manish Dikshit, unfortunately, due to some concern, he is not able to join today. Our next session chair is Dr. Devarshi Pallavi Bhatt from Manipal University, Jaipur. We welcome you, ma'am. Dr. Devarshi Pallavi Bhatt is currently working as a professor in HOD, Department of Computer Applications, Manipal University, Jaipur, with more than 35 research publications that is in reputed journals and presented international conferences of repute in India and abroad. Dr. Devarshi Pallavi has delivered keynotes and invited lectures in India and abroad, including MIT, BIS, NITs, IITs, to name a few. She has been awarded with Pratibha Samman and Shodh Shastri Samman for doing PhD in wireless sensor networks. A Best Researcher Award by Manipal University, Jaipur in 2020, November, and Best Researcher by Institute of Technical and Scientific Research for doing good quality research publications. We welcome you, ma'am. Our next session chair is Dr. Rekram Jangel, sir, from Department of Information Technology, NIT Raipur. Dr. Rekram Jangel, sir, is currently working as an assistant professor in NIT Raipur, Department of Information Technology, and he has published more than 50 research papers in reputed journals of repute. Thank you, sir. We welcome you, sir. In such a short notice, you are chairing this session. We welcome you, sir.
Thank you.
Thank you, sir, for joining the session. May I request all the session chairs and participants to switch on their video. This is for the purpose of group photo. I request all the participants and session chairs to switch on their video. Thank you. In this session, we have 5 papers to be presented. With a permission from session chairs, may I request session chairs to start the session?
Yes, sir, please, we can start it. Thank you.
Thank you.
Sir, go ahead.
Yes, thank you, sir. With a permission from session chair, we invite our first presenter having a paper ID 117, paper title as Fault Detection and Elderly Monitoring System using the CNN. It will be presented by Mr. Vijay Mohan Reddy.
Yes, sir, I'll be present. Yeah. Yes.
I'm making you the co-host.
Okay, sure.
Mr. Vijay, please share your screen and start the presentation.
Yeah, sure. Just a minute.
I just wanted to inform all the participants that please keep in mind the timing of presentation. It should be summarized within 10 minutes and extra 2 minutes may be allotted for queries. So please be aware with the timings. Thank you.
Yeah, good afternoon, chair members, and thanks for giving the introduction. And today my paper is on fault detection and elderly monitoring using CNN. And the co-authors for this paper are Rashmi and Natesha and Ramohan Reddy, Professor Ramohan Reddy, sir. And I've completed my master's from MIT. So let's begin the paper presentation. So the main so in the recent times where there are many challenges in the medical field where we find this fatalities in this case where the elderly people are not being taken care well, or there might be some negligence, or there is no person like at the time of the injury which causing to the fatality. So we want to reduce this high impact factor and trying to reduce the risk in real time and try to provide the real time feed with less response time. And we want to address this situation as this fall events are really dynamic in nature. We cannot predict them well before they could occur, so which could cause to catastrophes and later leading to death. So this is a motivational and background behind this paper. And in the recent time, there are many methods like they're trying to track this fall case situations using body orientation and detecting the movements using 3DR and this the body movements using 3D models, which were predicting this fall events, but the accuracy in this case was pretty low because the body orientation depends. It was varying from different person and the personality of the persons, and so there were some false negatives in this case and false positives as well. So, and there is a wireless connection based systems were built which were based on this network and bandwidth. So in case of this network issue, and we couldn't address the situation for some time. So there is some downtime in this case, which is a disadvantage in the scenario. And the other is using smartphone based applications like Android based using supported tensor and attaching to the waist or to the body attached sensors. So in this case, the stream in the data is being blocked in case of this buffer is overflown or the memory of this device is full. So there is some bottleneck between the devices and the sensors, which was a key disadvantage we were identified, and we want to reduce that as well. And there's a transit optimization and using fault detection and machine learning based models. So in this case, using this integrated devices, which will be running this background daemon scripts, which would be initialized in those devices. In case the device is disconnected from the network, the daemon fails and we cannot recognize any further, like there is even some downtime. So this is existing methods in that case. And the aim of this paper is identified in 2 parts. Like one is to recognize this fall events using in a very less time. The response time is a key factor, and also the accuracy of the model should be pretty high. And it also depends on the features, the type of features you're trying to extract, and then how many channels we're including in this. So this is a high-level diagram of how we have pictured this scenario where we are trying to capture the real-time sensor data using these videos, and where in hotspots where the elderly people were, there's a lot of accidents happening in those regions. So we set up these workstations which would employ capturing of the sensor data first, and then once the relay is in place, then we can transform the sensor data using something called as RGB intermediate representation, that's called bitmap images, where we use 3-channel RGB images, which is summarization of the sensor data captured from this body movements and also from the video based data. So, and this is a deep learning model, which is a 2-layered deep learning model, which is following by 2 convolutional and 2 max pool layer. And once the classification is done, we are going to alert the user based on using mobile devices or through some means so that someone can address the situation before any catastrophic. So this is the intermediate representation where we are trying to represent the angular velocity and the acceleration combined together, which would determine like what type of action exactly is being happened, whether the person is walking, running, jogging, running, falling, or what is the exact movement happening. So combining these 2 data into an RGB form, we could summarize this data using a normalization of these 2 sensor data, angular velocity and acceleration. So which is a RGB bitmap image. And once we have this representation in place, this is a summarization of all the data that we require. And then we're running into 3-channel RGB image, which is mapped to whatever this XYZ axis of that sensor data. So each channel is going to analyze each one of these features, and combining these features together would be much more exact, meaningful representation, and the output is pretty accurate in this case we're trying to measure. And comparing this model like with some of the existing methods, like there are various methods used, but the main focus here was on the accuracy based, like how accurate these models using different algorithms they are performed compared to our model and the features we have extracted in the way. So this is our perform like threshold based fault detection CNN has outperformed most of the existing methods. And this we have performed is on a transit based iterations, and where every day we get new data and we try to train it, and over a period of time the model is going to become accurate. So it's not like stagnant at one place, so it keeps on learning, and every single day since the workstation is up and running all the time. And these were the various daily based activities that we are recorded at high, like even it was the highest accuracy was achieved in walking, and somewhat in jumping there was a lot of displacement in the action and angular acceleration and velocity. So there were some deviations because of it. The accuracy is somewhat low compared to other actions. So as I was saying, like we were able to achieve this minimum response time, and this response time is going to decrease over time. And using this, we are able to detect the sensitivity at 100% and specificity of 96%. And the overall accuracy was average of these two, which is close to 97 or 98%. And as we know that this model is trained, and once the model is accurate enough, we can deploy at various stations. Just we need to purchase this workstation and employ at that various hotspots where we are trying to address the situation. And so the cost of this would be much more less, because it's not for only one-to-one basis. So we can employ at some hospitals where multiple elderly people might be walking around and in those areas. So, and since you are using a threshold-based devices, the sensor devices are much more cheap and efficient, like cost-effective solution for identifying this real-time fast computations. This is all my presentation, and these are some of the key references using multi-sensor fusion, and some of them are in this AI-based method. So we have got some inspiration on this from these papers. Thank you.
Okay, Vijay sir, I have one question.
Okay.
Can you tell me how did you make the bitmap image? What exactly in it?
Yeah, exactly. The bitmap image is just a normalization of this XYZ axial data. Like as you can see, this is exactly the one is the acceleration XYZ data, and the other is angular velocity. So it's just we are transformed that into an RGB coordinates. So it would be like.
So it's two values. Okay. I think the connection is being disturbed.
Mr. Vijay, are you there?
Yeah.
Any?
Can you hear me?
Yeah. Yes, sir. I can hear. Yeah.
Okay.
Actually, power has gone, so I just reconnected. Yeah. Okay.
So just let me know what are the three values that you are making the RGB image of.
So the three values were the XYZ axis. So this is just a transformation of XYZ axis into
XYZ
RGB.
axis of acceleration, XYZ axis
Yes,
of
yes.
angular velocity.
Yeah,
And what
angular
is the third value?
velocity and acceleration into RGB coordinates. So it would be like, let's say the sensor value is a peak sensor value of 16, so it will be plus or minus 16, and the sensor value will be within that range. So we are normalizing that. So sensor value plus peak value into 255 divided by the actual value.
That will be the third value.
Yes, that will be the coordinate, exactly.
Okay, just one more. What is the training and testing rate?
Yeah, training rate the training rate, we have used adaptive training model where the training rate is going to be adjusted as
how
per the
much
model.
data is trained for training? How much data for validation and testing?
Yeah. So actual data is based on the, so we just perform this training on like 20,000 videos. Like these were the videos captured in real time.
Can
And
you
the other
percent, how much data? 75%.
Yeah, 80%.
80% for training.
Yes, yeah, and 20% for testing. And
And
later on, the live feed will provide the data. So
no, you have compared your model with other models.
Yes.
Do they use the same same scenario that they are also using 80% of training and 20% of testing, like that?
Yeah, in some methods they were using like the machine learning based methods. The other methods are they were using like around 75%, 75 and 25.
Because that will not be a fair comparison now.
Yeah, but I've like summarized, I've collected all these papers where they are close to our training rate, like what is a fraction we have selected. So it's very close.
That's it.
Yeah, I have one question.
Okay.
Yeah, what is the source of your data? Source of data.
Source of the data is yeah, exactly. Okay.
Just tell the data set name.
So the source of the data is this gyroscope, and one is for measuring the angular velocity, and the other is accelerometer. Yeah, sysfall data set.
Okay.
The sysfall data set.
Okay. Fine, thank you. That's all.
Yeah.
Okay, I have one question, Vijay. Hello.
Yes.
With continuation with
yes, sir. Yeah, you are audible.
In your comparison table, all papers of other papers, some comparison, all papers have same data.
Yes, sir. Can you repeat again? It's
in your comparison table. Yes, in your comparison table, all papers have same data. Same data.
Yes, same data. Sysfall data and this mostly from sensor data. Whatever data I'm considering, it's based on angular velocity and acceleration. The same data.
Okay, means source of all paper is same.
Yeah, source of all paper is same, but mostly the comparison is based on angular velocity and acceleration. So whatever summarization I'm doing to represent my features, they are using some other feature representation. But whatever feature representation we presented in this paper is much more efficient.
Okay.
Yes.
So why you choose max pooling? Why you choose max pooling?
So max, we tried different different approaches, but this worked out well in our case.
Okay, there is different types of pooling techniques.
Yes, correct.
This one of them is max. So why you choose max only?
Yeah, because in most of the cases, the peak value or this, we want to identify the peak value. That is where exactly the fall happens. The other time of the time, the sensor data is constant. So for this feature representation, max pooling works well.
Okay, how you justify max pooling is giving best effort, best efficiency?
Because in other scenarios, since we want to capture the peak value, so in each window of the sliding window, we have that cascading of that window, so it is going to capture the maximum value. So
okay, how is it compared to other max pooling techniques? Compared with other pooling techniques?
Yeah, other pooling techniques I've tried, but the accuracy was not better, like compared to them. It was not giving better results.
You have not mentioned, just why I'm asking you.
Okay. Okay.
Okay, fine. Go ahead.
Thank you, Vijay. Thank you, session chairs.
Okay.
Should I proceed for the next paper, sir?
Yes.
The next paper ID is 230.
Yes, sir.
The presenter is Miss Reshma. Thank you, Vijay. Presenter is Miss Reshma MR. Miss Reshma MR, are you there?
Yes, sir. Am I audible?
Yes. Please switch on your video. I'm making you the co-host.
Okay, sir.
Yes, please go ahead for sharing your screen. In the time being, I request all the session chairs to kindly fill the evaluation sheet provided in the Google form link so that best paper award can be decided and finalized. Thank you.
Yes, sir. Yes, sir. We are doing that. Thank you.
Thank you, sir. Reshma ma'am, please share your screen and start the presentation.
Yes, sir. Thank you. Is my screen visible?
Yes, ma'am, it is visible.
Okay. Good afternoon, and all. My paper is Recognizing Indian Classical Dance Forms Using Transfer Learning. My name is Reshma Ambar. I'm a research scholar at Department of Computer Application, KISAT. My co-authors are Kannan V and Jagiraj VP and Sabu MK, my professors at the department. These are the topics we will be seeing: background, literature survey, problem description, methodology, result and discussion, conclusion, and references. So as we know, we are living in a digital age where everything is getting computerized. And that's even in case of our heritage or performing art forms as well as. So the Indian classical dance, which encloses in the performing arts along with other folk and traditional dance forms, which are all related to our culture, specifically in Indian culture. And for preserving these cultural heritage, we need to, like from the part of computer, we can actually do a lot of things, like from the part of preserving them, it includes categorizing them, identifying them correctly, etc. And we could do this for the forthcoming generation so that they will have an insight on the cultural heritage which they are having. So when I was going through the literature regarding Indian classical dance form or the work which has been done in this area, most of the work are focusing either on one particular dance form or on how the postures and gestures are being utilized to identify a dance form. There were very less paper where they are trying to recognize the dance form as such from an image or in a video. And maximum research was focusing on a single dance form or analyzing how the poses and hand gestures can be utilized to identify them. So, and also the different technology which we were being using in case of feature extraction or in case of classification was different. Like it includes the traditional image processing method to deep learning method. In case of image processing method for feature recognition and all, they were feature extraction, all they were using HOG and all. And also the all machine learning models like SVM and etc. are being used. And in deep learning method, I have seen that one or two paper have tried to recognize the dance forms using CNN, that is convolutional neural network. So in this paper, I'm trying to propose a framework which is capable of recognizing a dance form, and it is relying on the deep learning methods, and I'm using transfer learning for feature recognition and a deep neural network for the classification purpose. And another important thing which we identified at the time of literacy survey is that there is no standard data set for interclassical dance forms. And the data set which we have created is actually a handcrafted data set which has been collected. And I'm restricting the number of dance forms here in my work. It has been restricted to 3 dance forms like Bharatanatyam, with origins in Tamil Nadu, then Kathakali and Mohiniyattam, which is from Kerala. So this is the methodology. So in this dance form recognition system, basic thing is to identify a particular dance form, correctly classify them into these 3 classes. So this is the pipeline we are having. I have a set of data set, and these images are actually we are sending them for transfer. I'm applying transfer learning on this data set to extract the features. So the different transfer learning methods were utilized, and I obtained a very good result with ResNet 50. So those features are collected and using the classifier, which is a deep neural network, which we defined for the classification purpose. And the evaluation metrics which we have used is accuracy and also confusion metrics, which is actually visualized using the heat maps. And I achieved result was actually compared with the existing method which people were using for identifying the dance form was CNN. So I have done a comparison with CNN, and also a ensemble classifier was created to compare with the result obtained. And comparing with both of them, the transfer learning method which we were proposing was getting commendable accuracy. The model with ResNet 50 and deep neural network, it obtained an accuracy of 97.05% accuracy. So this is the comparison table. In the first table, comparison of accuracy of pre-trained model with deep neural network. So I trained the data set with I extracted features using different pre-trained models like ResNet 50, VG16, Exception, MobileNet V2, DenseNet, and Inception V3. Among all of them, I obtained a better accuracy result with ResNet 50. So that's the one which I consider to compare with the rest of the result. So I use the features which is extracted using ResNet 50 along with a CNN in 5-fold, and I obtained 88.58 accuracy while we were comparing it in CNN. And when I use the same to compare with an ensemble classifier, I used logic regression, random forest, Gaussian neighbors, and voting classifier. These were the ones which were having better result in the previous literature survey papers. So they were having logic regression 95, random forest 75, and Gaussian around 83, and voting classifier 84. So comparing with all of the 3 methods which we have used, ResNet 50 plus DNN was having better accuracy result 97.05, and ResNet plus CNN it is 88, and ResNet with ensemble classifier it was obtaining only 84. So we proposed a framework which is capable of recognizing Indian dance forms, and the core component of the framework was the deep learning methods of transfer learning and deep neural network. Transfer learning was utilized to extract the features alone. We are not using them for the classification. For classification part, we designed a deep neural network, and it gained a commendable accuracy in classification. The method showed outperform both when we compare it with CNN as well as ensemble classifiers. These are the references which I've used in my paper. Thank you.
Yeah, I have a few questions. It was a nice presentation. It's a nice concept also, and has not been covered as mentioned. So I have also not seen this study. But what is the use of this study?
Ma'am, we are having like computer dance form or its modeling. They are having a lot of advantages. Like in case of self-learning, nowadays we are having everything online, so people are tending to learn. Then also in case of tourism industry, in various areas they would be having like people can have an exact knowledge. Even in case of schools and learning purposes, we can use this method to identify the dance form exactly. I am restricting now only for the classical dance. We can extend it to the traditional and other art forms also.
And you have taken 3 dance forms only?
Yeah, ma'am, because as I was telling ma'am, we were having this restriction of data set. Like I had to collect it and I tried to balance it in such a way that I got for them correctly. But there is no standard data set as of now. I don't know there is any, it's not available. A standard Indian classical data set is not there.
So how many
So
images you have taken? I mean, you have
my actually the number of images were very lesser. It's around 360, and I tried to divide them equally only.
Okay.
But that was the another reason why actually I choose transfer learning method, because when we are using transfer learning for feature extraction, it actually help in reducing the number of larger data sets. So even if we are not having a larger data set, we will be getting a very good features from by using transfer learning method.
And if you can mention a few features which you have taken for consideration.
Ma'am, yeah, I actually used it like from the images, they would be taking it using transfer learning method, no, ma'am. So we cannot say exactly what type of features they would be learning. Like my in these transfer learning pre-models were actually trained on the ImageNet dataset.
Okay, okay.
So
So
similarly,
attire,
they would be applying.
maybe the attire also is
Maybe they
the.
would be the attire, the
Okay,
colors, etc.
fine. So that's all from my side. Thank you.
Thank you, ma'am.
Okay, one question from my side, Reshma.
Yes, sir.
Can you just tell me in simple words what you consider that the novelty of this work?
Most of the people, in case of classifying the dance form, they are actually going behind convolutional neural network. And it is good in case of when we are having a larger data set, it is very good. But when in this case, we are having a very lesser amount of data, like even if we are collecting it from internet or from by using other method. So in such cases, using this transfer learning, that too for feature extraction that was never tried before. Most of the papers, they were using either traditional method for feature extraction. Others were using, that is those with deep learning were using convolutional neural network directly. So for feature extraction, I guess nobody have tried, and that is a novel method in this case.
But if you see that the no what the data set is not that is made by, yeah, there is no standard
Yes,
data set that exists for it.
there is no standard data set existing as of now.
Okay. So if I talk about transfer learning, you only tried
Yes.
VGG or 3 or 4 techniques. Have
No,
you
sir,
tried
I tried yeah, around six.
everyone?
Yes, sir, that
Everyone.
much.
Okay. So you only got the maximum with.
A ResNet 50, sir. I was
Okay.
getting a better result with ResNet 50. That's why I chose it.
Okay. Okay. That's fine. Good. Good.
Okay, thank you, sir.
Okay, Resma,
Yes,
which
sir.
method you got best and which method you got worst?
Uh, like regarding feature extraction, you are saying, sir?
No, classification accuracy.
Can you repeat, sir? I didn't catch you.
Which method you have got highest accuracy?
Highest result I was getting with ResNet 50 and a deep neural network, sir.
Okay, and which method you got minimum accuracy?
Uh, in case of this one, I think. Just a second, sir.
Yes, this
Uh,
one. Yes.
in
Go.
88 with exception,
Okay.
it was obtaining around 88 plus
Okay.
88 percentage.
I think 86 is also there. V3 exception with 3. 86.
Yes, sir, 86. Sorry, sir. 86 is with
So,
exception.
so
Inception
what?
V3.
Okay. So what are the reason behind it? One is performing best and one is performing worst.
Either it would be how they are capturing the features of, like it's been, all of them are being trained on the image data set itself. Sorry, image net data set, I think. But how much they are capturing, it depend on their architectural, and ResNet 50 is considered to be an advanced architecture comparing with the others. And obviously they have the differences in which domain we are applying. Like Inception V3 and all, I think they work better in case of medical images at times. And ResNet, I think someone have used ResNet 34 till 34. Somebody has used. There also they were getting, but not as good as result as I have got.
Okay, input size of in size of images, input images, input
Yes,
na size of input images of both architecture is same or different?
Actually, it was different. It was having a set of varying size images.
Yes, that's why I'm
Yes,
asking you.
maybe that is also a cause why they were not performing as good.
So input of both architecture, both method is same or different?
Mm. Which method you are saying, sir? I'm not.
ResNet and infection with.
In every method, I have applied the same data set, sir. Among them, ResNet was the one which was giving me the better result.
Okay.
All of them were applied to the same input data set. Yes, sir.
Okay. Go ahead.
Okay. Okay, sir. Thank you.
Thank you. Thank you, session chairs. Thank you, Reshma. And
Thank you,
should we
sir.
proceed for next paper? The next paper is 344 paper ID and will be presented by Mr. Swastik.
Good afternoon, sir. Am I audible?
Yes.
Okay, so I'm sharing my screen. Sir, host disabled participant
I'm
screen.
making you the co-host.
Okay, okay, sir.
For a second.
Okay, sir.
Yes, Mr. Swastik, you can now share your screen.
Okay, sir.
Reshma, Mrs. Reshma, please stop sharing your screen.
Sir, is my screen visible?
Yes, yes.
Okay, sir. Sir, can you just tell me how can I just hide this this box like on the side of it there?
Which box?
Sir, it is above the Springer Scopus, something black like talking Swastik Kumar, the Zoom, the menu of Zoom meeting. Or is it okay if?
It is okay. You start from.
Okay, okay, sir. Okay, sir. Is it visible now?
Yes, yes.
Okay, sir. So good afternoon, everyone. I am Swastik Kumar Sahu, a student of NIT Bhopal, and I have presented the performance analysis of ResNet for facial emotion recognition. So basically, that I have not mentioned the literature review as we are having a lack of we have lack of time. So I will just tell about the problem statement and my proposed methodology and results. So as the previous presenter have already discussed that ResNet was performing better than CNN. It is quite similar to that. So everyone uses CNN for image classification, and emotion recognition is also a kind of image classification, right? Like we are classifying different type of emotions, anger, speech, etc. But what happens, the CNN suffers from vanishing gradient problem while training the model using backpropagation algorithm. So we have proposed a ResNet model and we are checking how it is performing for emotion classification. So as we know that while training the model, the formula for weight is old weight minus learning rate into the gradient. So what happens when we are using a deep neural network, there are multiple layers, then this derivative becomes product of many derivative while applying the chain rule. And if each derivative have very small value like 0.1, 0.02, then the final value, this value becomes almost near to zero. So new weight becomes same as old weight, and weight doesn't update, and the model stops learning. This is a problem of what happens in CNN. But to solve that, ResNet model has been proposed, which uses a skip connection layer. So okay, so I think I have not added. So what happens? We just add the input to the end to stop this vanishing gradient problem. So this is the proposed model, and here I'm going to explain one by one. So here first we are using zero padding. Our input is of 48 cross 48 pixel images. So after zero padding, it will be converted to 64 cross 64, means we'll convert it to 2 to the power something. Then similar to the CNN, the convolution layer is there for feature extraction. Then normalization is there, means every pixel has a value from 0 to 255, so it will be divided by 255. And in this model we have used both max pooling and average pooling. So after max pooling, there are two rest block, which is called as the residual blocks. And inside the residual blocks, I will explain later, there is one convolution block and two identity blocks. And finally, it is same as the normal ANN layer, the flattened layer, dense layer, and finally emotion classification is done. But now inside the convolution block, and this is there, and inside the identity block, this is there. So in identity block, we are just adding the input at the end, but in convolution block we cannot just add this, because here max pooling is used, convolution max pooling based on, so the size will be different, and to add two images the size should be same. So we have we have also added here the con2d max pooling and batch normalization. So we have trained this model for 30 epochs, and we found the accuracy graph which has been plotted here, and the graph of training and validation loss, and we have plotted the confusion matrix, right? Here we have 5 emotion class, 0 for anger, 1 plus disgust, 2 for sad, 3 for happiness, and 4 for surprise. We have nearly 25,000 images, which has class 90% for training and 10% for testing, and nearly more than 1 million trainable parameter is here. So here we can see that this value, the one, it is very small, like 14, but this is not an error because the predicted value are not different, which can be justified later. In this image we can see that for disgust there are very less number of sample images in the data set, which I have also mentioned, whose link I have also mentioned in the reference. So as it has a less number of sample images, so obviously a less number will be detected because it already has less number of images. And we can say that after training the model for just 30 epochs, it has nearly 79.91% of accuracy. And finally I have plotted some sample images with their predicted and actual emotion class. So we can see that there is an error, like it is predicting happiness, but the actual value is anger. So we can also add a more number of residual blocks. We can test with different batch size. I have taken the batch size as 64, and we can also try with both max pooling. But I found that while using max pooling and average pooling both, it was giving better performance. In my paper, I have mentioned the performance of CNN, which I forgot to add it here, because for the same data set, for the same number of epochs, and for the same number of layers, this model is showing 79.91%, whereas CNN was showing around 72% of accuracy. For the same data set, same number of epochs, and same number of layers. So I have, and this is my reference, and thank you. Okay, sir.
Yes, any query from the session chairs?
No, sir. No, sir. It is fine.
Shall I proceed? Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
So why you choose only ResNet? There is a lot of different techniques.
Sir, Sir, what are the different techniques? Can you please like FRR, CNN, RCNN? Those are.
Yes, sir. There is different types of the transfer learning technique. I think this is a transfer learning technique.
Sir, this is because generally CNN is being used for emotion classification.
Yes,
And
CNN used for image, no? Image data type. Okay. So mobile net, StateNet, Google Net, AlexNet, Egyptian Net. There is different techniques. Why you choose only this one?
Sir,
because you have not compared another technique.
Sir, I have compared. I have mentioned that in my paper, which I have submitted, but unfortunately, I have not added that table here.
Okay.
But
then
sir,
you choose only 90-10 ratio.
Yes, sir.
Why you choose only 90-10?
So there is no specific reason for choosing that. I just randomly took 90% per training, and there is no specific reason, sir.
Okay, it may be better accuracy in 80-20, maybe. Okay.
Okay, sir. I can do that. I can try with the.
So why you apply padding?
Sir, because sir, because I have to change this to the to 2 to the power something. My input image was of 48 cross 48 pixels, and I wanted to convert it to 64 cross 64. So that's why I added zero padding, sir. Okay, sir.
Okay, Swastik. Can you
Okay,
hear?
sir. Okay, sir.
Hello.
Yes, sir. Thank you, sir. The next paper ID is scheduled, that is 420, will be presented by Mrs. Uma.
Yes, sir. Shall I start the presentation now, sir?
Yes, ma'am. I'm making you the co-host.
Okay. Okay.
Okay, go ahead.
Thank you.
Thank you.
Yes, ma'am. You can share your screen.
Yeah, 1 minute. One minute.
Yes. Yes, ma'am. Are you facing any difficulty in sharing?
Yes, sir. 1 minute, sir. It's opening right now. Will you be able to see my screen now?
Not yet, ma'am.
1 minute, sir. Sorry for the delay, sir.
Yes, ma'am. Any difficulty?
Yes, sir. It's unable to open right now.
Oh.
Will you be able to share my screen, sir?
Sorry, ma'am.
Will you be able to share my screen, PPT?
Okay, your it will take time, ma'am. I need to find out.
Yeah,
your
1 minute,
PPT.
sir. 1 minute, sir.
Or by the time you resolve your issue, we may move to next paper.
Sir, will you be able to see my screen now?
I don't think, not yet, ma'am.
Okay, sure. I'll join the next one.
Please remain joined. We
Yeah,
are
yeah. Okay, sure.
approaching for next presentation, and
Okay.
after that we will please resolve your issue if any.
Sure, sir.
Okay.
Thank you, sir. Thank you.
Next is 440, Miss Ananya.
Yes, sir. Could you make Ankita the co-host, please? She will be sharing the slides.
Okay. Ankita P. Isn't
Yes.
it? Yes. Okay.
Thank you.
Yes. Okay. Okay. Sorry. 1 second. Yes, Ankita P is now co-host. Please share your screen.
Is the screen visible?
Yes, it is visible.
Yeah.
Good afternoon. We present you our paper titled Deep Learning-Based Pipeline for Detection of Multiple Ocular Diseases. The study has been carried out by Ananya, Parul, Anish, and myself, Ankita, undergraduate students at PS University, Bangalore. So we have done this research under the guidance of Dr. Gauri Srinivasa. Background. So visual impairment is a common problem and the world faces considerable challenges in terms of availability and access to the eye care. So most of the diseases of the eye, they manifest themselves in the retina, which can eventually lead to complete blindness. Hence, it's very necessary that we prevent them by timely detection. So the retina, it serves as a window into our body and offers a non-invasive way of screening for both ocular as well as systemic diseases. So previous models exist for certain common diseases like diabetic retinopathy or glaucoma, but in isolation. So, but it's very necessary that we detect multiple diseases simultaneously so that the rarer conditions do not go undiagnosed. So our project aims to develop a model to detect a wider range of diseases, including the more rarely found diseases from a single fantasy base. So the major learnings from our literature survey include, so there exist state-of-the-art models of few common diseases like PR and glaucoma, but they focus on a single disease. Also, the limitations of traditional image processing techniques and how deep learning-based methods outperform them for the classification task. Then the benefit of deep learning methods as they do not warrant significant domain expertise. Then the application of transfer learning and for DL techniques when you have limited training data set. Also, the presence of class imbalance problem in the training data set can tamper the performance of ML models and can lead to incorrect results. Now I hand over it to Ananya.
Thanks, Ankita. So like Ankita said, although state-of-the-art models do exist for diseases like DR and glaucoma, models that detect a single disease in isolation result in other diseases going undiagnosed, which means that we have to test for each individual disease separately. So our solution was to build a model that can detect multiple diseases together, and we've done this with the help of convolutional neural networks. Next slide, please. So before we go into the methodology, this is a quick look at our data. It was published in November 2021 as part of the RIAD Grand Challenge. On the left here, we have a sample image from the data set, and on the right, a snippet of the labels. So we have the identifier for the image, followed by disease risk, which is a binary variable, 0 or 1, depending on whether it's classified as at risk or not at risk, followed by labels for each individual disease. From the labels, we can see that there do exist images which are classified as at risk of more than one disease. So there are a total of 1,920 images in the training data set, out of which 79% are classified as at risk of at least one disease, and 24% are classified as at risk of more than one disease. There are a total of 29 labels associated with each image. This is a plot of the number of positive samples for each disease. We can see that for common diseases like diabetic retinopathy and MH, DR and MH, we have more than 300 samples, but this number falls sharply as we move away. This means that there is significant imbalance present in the data set. Instead of considering all 28 diseases, we've chosen a subset of them based on the occurrence classes, since the result can easily be extended to other diseases in the same class. So we have the high occurrence class with 300 plus positive samples, 2 diseases from this class. Moderate occurrence is 100 to 150, and low occurrence is less than 100 positive samples. These are a few samples from our training data. So as we can see, each disease has a different diagnostic procedure. For example, if you look at image 1, diabetic retinopathy is diagnosed by the presence of exudates, the bright yellow deposits. While if you look at image 2, media haze is characterized by a blurry or opaque appearance of the cornea. Hence, a feature-based approach considering each disease separately would be quite extensive and would require a lot of domain knowledge. On the contrary, a deep learning based approach can be applied uniformly across all diseases. And since it helps because the neural networks can detect the features themselves. So I'll now hand it over to Parul to speak about a methodology.
Yeah. Thank you, Ananya. For our methodology, we tried a variety of methods to determine which model works best for which disease. For our first approach, we trained a vanilla convolutional neural network for each disease. Given here is the architecture of the model for the same. We also performed real-time data augmentation to increase the amount of data for training. These are the results we obtained from the vanilla CNN. As we can see, for diabetic retinopathy, that is DR, and media haze, that is MH, which are the high frequency diseases, decent results are obtained in terms of accuracy, sensitivity, and specificity. However, for the mid to low occurrence diseases, the sensitivity obtained is very poor. To be able to predict such mid to low occurrence diseases, there is a need for utilizing methods which require much lesser amount of data. So for our next approach, we used transfer learning based approach, from which we used the efficient net, which is pre-trained on the ImageNet database. By following this approach, we saw a slight improvement in the sensitivity and specificity values for detection of the mid to low occurrence diseases, as shown in the green color. As noted in our EDA previously, there's quite a huge class imbalance in our dataset, and this imbalance makes it hard for the features to be learned by the model. To reduce this amount of imbalance in our data, we decided to construct a representative dataset from our original dataset. In this representative data, the ratio of positive and negative samples for a particular disease were maintained to be almost equal. Following this approach, we saw a marked improvement in the sensitivity and the specificity scores for the detection of the mid to low occurrence diseases, as is shown in green color. In conclusion, this table is showing the progressive improvement that we got for detection of the mid to low occurrence diseases as we moved from our CNN-based approach to transfer learning-based approach, as shown in the blue color F1 scores. Given here is our proposed prediction pipeline for detection of multiple ocular diseases from a single fundus image. First, the fundus image will be given as an input.
Sorry to interrupt. Please quickly summarize the work as we are running short of time. Thank you.
Sure. The disease risk is predicted using the efficient net model, and if the disease is detected there, it is then tested for the presence of each individual disease.
So we tested this pipeline on a subset of the test dataset provided by the contest organizers, and this summarizes the performance. We can see that it works quite well for mid to low range diseases. That is, if you look at ARMD, 77% of them are correctly classified, and all the not at risk samples are correctly classified. Next slide, please. So yeah, just to conclude, for our high frequency diseases, we saw that the vanilla CNN approach gave the best performance, which can be attributed to higher amounts of data available for learning. And for moderate to low, a combination of efficient net along with representative data set was found to work best. In conclusion, so in this project, we've built a deep learning based pipeline for detecting multiple ocular diseases, and we've given special focus on solving the class imbalance in our small data set. And for diseases with very few samples, less than 100, we found the transfer learning based approaches yielded better results. And stratified random downsampling was found to improve recall and FN score. Another note is that for diseases with very few samples in single digits, we haven't included them in this study because deep learning based approaches would not be appropriate there due to very limited data availability, and we are looking at implementing a rule based approach for that. Thank you. We're now open for questions.
See, this classification is a old problem. So what is the novelty in your work?
Yes, ma'am. So the novelty is that we are combining multiple diseases, and it avoids having to screen for every disease individually because it's happening in one pipeline.
And from where you have taken this database?
This was published as part of the Grand Challenge, which happens every year for medical image analysis. So it was published by a hospital in Mandate. Yeah, November 2020.
Okay. Okay, that's all.
Nanya?
Yes.
I know CNN, okay, but what is the vanilla CNN?
So, sir, we're just calling it vanilla CNN here to differentiate with our other efficient net models. So, vanilla CNN is trained from scratch. Efficient net is a transfer learning model which has been pre-trained on ImageNet, and we're just fine-tuning it to our data.
Okay, I know other method, but is there any meaning of vanilla?
No, sir. No, we're just saying plain CNN, not transfers. That is how
What are the architecture of CNN?
Oh yeah, Ankita, can you go to that slide? So this is the architecture that it is.
Okay. So how many layers of different particular of CNN?
Yes, sir. We have around 6 max pooling layers here. And then the rest are convolutional layers. We have 16 filters in the first layer. And the kernel size is 4 cross 2.
Okay. So what do you understand by kernel size?
So, sir, that is the window that is used to train, window size basically.
Is there any use?
Sorry, sir, could you repeat?
What are the use of this kernel size?
So, sir, the smaller the kernel size, I think the more learning, I think it affects the, so if you have a very large kernel size, your model might be lightweight, but your learning might not be as fine-tuned.
What happens in case of larger or smaller kernel size? Is any effect?
I'm not exactly sure, sir.
Okay, go ahead.
Okay, so the only problem that I have is that why did you only use one technique for class imbalances? Have you tried others like random sampling?
Yes, sir, we did try random oversampling as well. And out of all those, random downsampling was found to yield the best results.
Okay, you have tried SMOT also.
SMOT also, yes.
Okay, so only this one produces the best result.
Yes, sir.
How many techniques have you tried?
So we've tried oversampling, SMOT, and this one.
Only 3.
Stratified, yes.
There are
so
more
these were the 3. Yes, sir. But these were the 3 main that we found in the literature study.
Okay, that's it.
Okay, our next.
Thank you.
Mrs. Uma, are you ready with that?
Yes, sir.
Yes. Yes, now you can share your screen.
Yeah, 1 minute.
Yes, sir.
Will you be able to see my screen, sir?
No, ma'am.
Sir?
Ma'am, not yet, ma'am. Can you share your PPT? Yes, ma'am. Now it is visible.
1 minute, sir. Will you be
Yes.
able to
Yes,
see my
yes,
screen?
yes.
Sorry for the disturbance, sir.
No
And,
issue.
good afternoon, one and all present here. I'm P. Uma Maheshwari, research scholar from Cambridge College of Engineering. I'm going to present a paper entitled Shallow CNN Model for Recognition of Infant Facial Expression. So these are the table of contents that I'm going to present now. What exactly the background of information that we have gathered for this particular application, and the base paper that has been taken for the literature survey, and the problem description, exactly what issues that have been facing for this particular application, and the methodology that has been implemented for the application, and the results and discussion. Finally, it has been concluded over here. So one of the important aspects of communication is the facial expression. It is a kind of a non-verbal indicator, which is vital for the interpersonal relationship, which can communicate through the facial expression easily. So there are around 7 universal facial expressions that are employed as a non-verbal indicator, which is love, cry, fear, disgust, anger, contempt, and surprise. And these universal expressions could be used as a key component for the automatic facial expression recognition. Because despite the fact that the human can understand the facial expression instantly and effortlessly, but it could be really a challenging problem for the machine. So compared to the adult facial expression recognition, infant facial expression needs more significant and a challenging computer vision problem in today's environment. So these are the literature, like out of all the review literature survey papers, these 2 papers need like giving more importance for this particular application. So one is a feature guided CNN for baby facial expression. This particular paper have been implemented 3 different kind of facial expressions like cry, laugh, and neutral. They have gained around 75% of accuracy by proposing the feature guided CNN approach. Second one is the ICOB data set. This particular paper have been referred by the reviewer, and by requisition, this particular data set has been implemented in the proposed methodology. So coming to the problem description, infant facial expression is one of the most important direction in the field of computer vision, particularly in the field of surveillance parental care, because most of the parents, they are leaving the child with some guardians or some of the housemaid with some kind of a surveillance environment. So this particular application play a vital role in intelligent interpersonal interaction. So the ability to accurately interpret infant facial expressions, and this could be the lead for the formation of professional parental care through the surveillance footage analysis system. But coming to this particular problem, the scarcity of the infant facial data set need to give more attention before getting to the problem. So first, because it's a recognition mostly based on the building of a data set. So the development of an automated infant facial expression technique becomes critical, and the need for an infant action database has become essential. So our proposed methodology will give the introduction of a publicly available facial expression dataset, which could contain around 5,400 images. And we are going to propose a reduced space and time constrained shallow network, which will work with a smaller number of datasets. And particularly, this particular data set will work for the infant facial expression recognition. And finally, the comparison have been with the existing network. The performance analysis have been carried out with the existing network. So initially, this is the model for the proposed shallow CNN classifier model. So first, we have started up with the data set collection. So the infant data set have been collected for the cry, loss, and neutral initially. So as we have seen, like more than 7 different kind of expressions have been available. So we are reduced into 3 initially because we are starting up with the proposal of a shallow CNN network, and particularly for the lower data set images. So we are trying with the cry, loss, and neutral information. So this data set have been collected from the infant action data set information, like nearly around 1,800 images have been collected for each particular expression for cry, loss, and neutral. So from the infant action database, 1,800 images for cry and 1,200 images for laugh have been taken out. And the remaining 600 images have been taken out from the website, and 1,800 neutral images were also being taken out from the website. So once we have created this particular data set, this has been implemented with a shallow CNN classifier model as we are working out with a smaller number of data sets. So this particular model have made up of 11 simple layers that has been created. So this particular model has 2 groups of convolution layers, 2 max pool layers, 1 fully connected, 1 softmax, and 1 classification output layer. So this group contains a 1 convolution layer followed up by the batch normalization and the ReLU activation function. So the input image has been given with a size of 224 into 224, and then it is convolved with a convolution layer, which has 64 different type of convolution filters, followed up by the ReLU activation loop. So the batch normalization performed like it will provide the independent learning capacity to the network, and the ReLU will provide the linearity to the network. So after that, the low-level features are extracted by performing the max pool operation. This highlights the important features in an infant image, and which would avoid like a fuzzy kind of issue. So again, I'm sorry, these features are again convolved with the 64 filters with the size of 3x3, again with the batch normalization, with the max pool and the ReLU function. So this structure reduces the learning parameters and improves the representation of features. So at the end of the structure, the fully connected attached with the softmax and the classification layer. So compared for the training, so this particular network has been trained around 70% of the data, like 70% of the data that has been used for the training, 15% for the validation, and the remaining 15% that has been employed for the testing. So out of 5,400 images, 1,800 has been taken for each class. So out of 1,800, 1,260 images have been chosen for training, 270 has been taken for the validation, 270 has been taken for the testing. So for the initial parameter setting, we have set the optimizer as a SGDM, which is a scaled conjugate gradient with a momentum. We have started up with a learning rate of 0.01. Then after 100 iteration, it will be multiplied with 0.1. With a validation frequency of 50, we have trained this particular model around a maximum epochs of 50 with a minimum batch size of 32 and the drop factor of 0.1 with a momentum of 0.9. So after we have tried all these training model, the simplistic and generalized architecture with stochastic gradient descent and momentum has been designed, and it is well suited for the new infant images, which will avoid the overfitting issues. So after several adjustments have been made in the model, the optimal training model has been selected. And this model that matches the recognition properties of 3 different facial expression of infant actions for a limited number of data sets, and the algorithm classifies the loss, cry, and neutral information. And compared to the results and discussion, the performance comparison have been initially trained with a pre-trained CNN, because most of the automatic facial expression which has been taken out for the adults, they have trained with the ResNet and VGG16. And these particular model have been compared with our proposed method. And it achieves nearly around 97.4 as an average accuracy for baby X data set, which has been collected from the internet and the infant data set. And for the 97.13 have been achieved for the ICOP data set. So again, this performance comparison have been compared with the VFESO DLSC method. This particular method have been given in the base paper. So they have achieved nearly around 75% of information, and it's given average accuracy of 93.6. Other than the base paper, this particular paper have been implemented for the existing method. But the data set has not been available for this particular method. So only we have taken out this method for the comparison purpose. So it achieves an accuracy of 93.6. So, and our proposed method achieves an accuracy gain of 3.53 compared with the ICOP bit, and a cross-validation accuracy gain of 2.36. And we have achieved a better average accuracy result of 97.4, which is about 3.8% greater than the existing method. So conclusion, we have proposed shallow CNN model, shallow neural network classifier model, which is a space-reduced two-stage model, which will work perfectly for the smaller number of data sets that has been collected from the videos and downloaded from the website. And this method will achieve the better testing phase accuracy of 97.8 compared to the baby X, and ICOP around 96.2, and which will take a lesser amount of time for the training with a perfect learning capacity. So this method will be well suited in the field of surveillance parental care, and it will be the promotion of professional parental care information, which will provide the intelligent interpersonal interactions. And these are the references. Thank you. Sure.
Okay, Uma Maheshwari.
Sure.
Go to proposed methodology.
1 minute.
Okay, this one. So convolution 1, 7 into 7. What is this?
7 cross 7 is the size of a convolution filter set.
Okay.
So totally around 64 convolution filters have been implemented with the size of 7 cross 7.
So what are the input size of your image?
Input size have been taken out for 224 into 224 because it has been taken out for the ResNet VGG16. So the same size have been maintained for our network too.
So why this specific size?
I'm sorry, sir, I couldn't.
Why this specific size is applied?
Because the ResNet and VGG16 have been implemented with the same size of 224 cross 224. Sir. So for the comparison purpose, we have taken out this particular size of information for our network too.
Okay. What is stride 2?
Stride 2 is nothing but like the sliding information that like once the convolution mask have been implemented with the input image. So okay. After 2 rows and 2 columns, like initially it will skip 2 rows, that is stride 2. So it will implement the convolution layer. Like if it is initially, if it is implementing 1,1, if it is stride 2 means it will implementing 1,3. It will skip 2 rows as well as it will skip 2 columns.
So after putting value is there, and where is dropout? Is there dropout or not?
Actually, the dropout has been fixed in the learning parameters, sir, which will drop out the information which hidden layer will not be useful for the next layer, sir. So it will drop out learning factor have been fixed for 0.1, but we are not adding any dropout layers over that. So the learning parameters have been fixed the dropout factor of 0.1, which will drop out any unwanted hidden information that has been overlaid on the hidden layers. Sir.
Okay. Why you choose only soft image?
Because we have tried with a different kind of classifier technique, sir. This softmax will give us a more reliable terms of accuracy. nearly around 97.4. We have tried up with some other kind of a classifier information, but we have got nearly around 80, 70 or 80 something.
Okay. Softmax and classifier are different. Okay. Both are not same. Softmax is a different and classifier is a different.
Softmax is a kind of a thresholding technique, like which will give you from which you want to move on to the classification for the law of cry and neutral. It is a kind of a thresholding technique, like it is like it will give you the information that what kind of a score value that you have for each kind of class.
Okay, so where you have taken data?
I'm sorry, sir, I couldn't.
Where you have taken data?
There, one data, like two of the data that we have requested. So one of the data that has been available from one paper, which is infant action database. From there, we have collected law 1,200 image and cry 1,800 images. Remaining 600 images for laugh and 1,200 images have been taken out from the website, sir. And after the reviewer comment, we have made a requestation to the ICOP with data set, and we have got this particular data set. This has an around 64 images of laugh, 64 images of cry. So we have taken this particular information for the results and analysis purposes. So that has been implemented over here.
Okay, this is comparison table. In your comparison table, there is a different techniques and different authors. Okay.
Yes.
So in this case, all authors have same data set.
No, sir. The first one, we couldn't unable to get the data from the authors. That we have made a requisition, but we couldn't get the data. So for that purpose, we have taken out the result directly from the paper. The second,
are you getting my point, Uma? How you compare if your database is not common? Are you getting my point?
Yeah, yes, sir. Because it's not common, it's not being available in any other data sets. That most of the infant database have not been coming under requisition, and we have thought
it's okay, fine, no issue, no problem. But if you compare others, if you have some same class, suppose you are studying 12th standard, you compare only 10th, 12th standard students, not 11th or not more than after 12th class. So I think database should be same if you compare your others.
Okay, sir. Because since based on the requisition we couldn't able to get, we have just made a information, and but for this ICOP data set, we have got it from the requisition, and we have implemented our algorithm, and we have got the results, sir. The proposed to CNN ICOP. And we have got
good. No issue. Your work is good.
Thank you.
Okay, it's over my side.
Okay, thank you.
Thank you, sir. Any other queries?
No, I have no.
Okay, thank you, sir. Since we have ended with all the presentations, on behalf of NIT Raipur and organizing committee of the conference, I thank you all the session chairs and participants for sparing valuable time as well as providing valuable insights to the authors. And it is kindly requested to all the session chairs to fill the evaluation sheet, and so that the best paper award can be decided and finalized. Thank you, sir. Thank you, ma'am. Thank you very much. We may end this meeting.
Joseph, I have not presented, sir. You have not called me. I'm supposed to present paper. My colleague is supposed to present paper 454.
Mr. Joseph, please state your paper ID.
Hello, sir.
Yes, Mr. Joseph. Hello, please state your paper ID.
454.
Yes, sir. 454 is scheduled on 4 p.m.
is here too. I've not presented.
Yes, this is session 4. 454 paper ID is scheduled on session 10.
Okay, this what section, sir?
Yes, this was session 4, sir. Your paper is scheduled on 1600 p.m. today. That is in Indian time, it is 4 p.m. today.
What about 455, sir? Because I know I have two papers. One is in this section. Sorry.
No issue, sir. And 455 is scheduled on 1500 p.m. today. That is in Indian time, 3 p.m. today.
3 p.m. today.
Yes, Dr. Dilip Singh Sisodia has mailed you all the relevant or WhatsApp you all the relevant documents. Today morning itself, they have again intimated you all the things. Okay, all the sessions.
So the two paper is not in this. It's not for this section.
Yes, sir. It was not for this session. But your presentation is scheduled on 3 p.m. That is 1500 p.m. today. But the link will be same for this.
So what's the time now? I'm in Nigeria. So what's the time we'll be there now, please? So I'll be able to know the exact time I'm presenting.
Okay. 4:55.
4:55 ना? 3 बजे वहाँ पे 10:30.
Mr. Joseph.
Hello, sir. I'm 455.
Yes, 4:55 is scheduled on that. Yes, scheduled on 10:30 according to Nigerian time.
Ajago Sunday is here too. I have not presented 455.
Yes, session 4 is over. Thank you all the session chairs. Thank you all the participants.
Thank you. Thank you, everyone.
Thank
you. And I have submitted this evaluation sheet. Kindly check.
Yes, thank you, ma'am. Thank you so much.